Hi, everyone. I'm Walter Zeisel, the Manager of Education Outreach at the Los Angeles Department of Water and Power. And today it's our first virtual chat for this spring. In fact, the last time we did one was last May. So today I'm just going to provide a short introduction. Also welcome you. This is also part of Engineers Week. Today's chat is a panel focusing both on the Ladwp renewable energy goals and plans, projects, but also on the three engineering disciplines and the work that is provided in this area. We have a mechanical, a civil, and electrical engineer, each of whom will share information about their backgrounds, how to best prepare for these careers, and also the work they do to implement renewable energy programs and projects. They will also share information on what roles their engineering disciplines do in other areas of Ladwp and also elsewhere. So now it gives me great pleasure to introduce the first member of our panel, Jay Lim, Manager of Integrated Resource Planning, who is also a mechanical engineer. Jay?
Thank you, Walter. So my name is Jay Lim. I've been with the Department of Water and Power for the last 12 years. Of that 12 years, I've been in the Integrated Resource Planning Group for 8 years, and 2 years in Generation Station Engineering and 2 years in transmission projects. I also have my colleagues here with me, Paul Lee, who's a civil engineer, and Luis Martinez, electrical engineer. The goal of today's presentation is to provide some background and insight as to what engineers do, specifically at the Department of Water and Power. At the Department of Water and Power, we have a tremendous amount of challenges because we have very progressive goals for clean energy and clean water supply. And so with that, I'll give a brief background on some of the initiatives going on at the Department of Water and Power, and then we'll talk about what each of these disciplines do. In general, engineers, if you're interested in math and science, it's a very good field for you to go in because a lot of the background math and science is needed. As you take classes throughout your high school career, if those classes are interesting to you, I encourage you to take more of those classes. And when you progress to college, you can select the engineering field of your choice. And that's all you need to graduate with the Bachelor's of Science. And then you can become an engineer at the Department of Water and Power or elsewhere in outside industry. So a little bit background on Department of Water and Power. We're the largest municipal utility, which means we're owned by the city of Los Angeles. We've been in business for over the last 100 years. We have over 10,000 employees and serve 4 million people within the city of LA to provide reliable, safe, and cost-effective water and power in an environmentally responsible manner. So this is a very exciting field to be in because we're able to contribute back to the community that we live in. In terms of the water supply and water system, we're transforming our water supply locally within the next 10 to 20 years. Currently, about 78% of our water supply comes from metropolitan water and the LA aqueduct, which are from long distances. But what we want to do is transform that so that we have a more resilient water supply that's sourced locally. So within the next 15 years, we'll be transitioning that over and reducing that 78% down to 29% of imported water. And we'll be also increasing our recycled water and groundwater from 13% up to 71%. That way, in case there's an earthquake, we have a more resilient water supply. On the same end, the power system is also undergoing a huge transformation. Currently, the state law is to achieve 100% zero carbon energy by 2045, but LA is always more progressive. We have a 100% renewable goal, and we're focusing on 2 studies that will help us get us there. The first is the LA 100. So we're partnering with the National Renewable Energy Lab to determine what it would take to get to 100% renewables, with the ultimate goal of eventually phasing out natural gas supply. And in the short term, by 2030, we have power plants that are cooled by ocean water. And because it impacts the wildlife, the aquatic organisms, there's an EPA law that we have to phase out once through cooling or ocean cooling by 2030. So we're also looking at how we will retain a reliable power supply by 2030, at the same time investing towards 100% renewables. And both of these will feed into our strategic long-term resource plan, which is we're kicking off this year, that will help us transition towards 100% renewables. Here's a trajectory of our renewable energy targets and how we plan to get there. And this is consistent with the Mayor's Green New Deal, which targets 55% renewable by 2025 and 80% by 2036. Today, we're actually trending towards 38% renewables. And in the next few years, we'll be bringing online several large solar and energy storage projects along with wind projects that will help us ramp up our renewables. Here's a snapshot of our power system. We have a very far reach in terms of the amount of power and energy that we import. As you can see in the map on the right, we import renewable energy from not only Washington and Oregon, where we have a lot of our wind projects, but also Utah and Nevada, where we have a coal power project that we're phasing out, along with geothermal and large-scale solar. We also have nuclear in Arizona, and locally, we need to retain a resilient supply. So we also have local power plants, 4 of them that are inside the LA basin. And we're quickly ramping up our local solar programs to help reduce the usage of gas at these power plants. And Ladwp is unique in that we're vertically integrated. So we own our own generation, transmission, and distribution. We are our own balancing authority, which means we don't rely on other sources within California. And we have 1.5 million customers with a $4.2 billion annual budget. Our hottest peak demand was in 2017, where we hit 6502 megawatts. And if you look at the left, we have a tremendous amount of distribution network and transmission, thousands of miles of overhead underground cables and transmission lines. Here are some examples of our existing clean energy programs that we put in service. Pine Tree was one of our first wind farms. It's 135 megawatts, and this was built by Department of Water and Power and owned and operated. It's one of our first, built in around 2010. Recently, about a few years ago, we commissioned Beacon Solar and Energy Storage, which is our very first energy storage, a battery project. And this is to help integrate renewables. We also have Don Campbell Geothermal as an example of one of our Nevada projects. And to bring all of these renewable projects in, we are vastly upgrading our transmission. An example is the Barron Ridge transmission, which we recently upgraded over the last few years. So this helps us to ramp up our renewables. In 2010, we were at 20%. Today, like I mentioned, we're trending towards 38%, and we'll continue to ramp up as time goes by. We're not only focused on external projects, but we have projects and programs inside the LA basin. And with these projects, these allow customers to participate in, and engineers also work on these projects to help administer the contracts and help oversee the technical aspects. So we have expanded feed and tariff program that is within our LA basin, as well as a net metered solar and community solar program. So these are solar rooftop programs that are very local to our area. Along with supporting our renewables, we are also supporting decarbonization of our transportation sector through incentivizing electric vehicles. So what we're doing, we're installing chargers throughout the city. We currently have 10,000 EV chargers installed in LA, and our goal is to ramp that up to 28,000 by 2025. So these are consistent with the mayor's goals, and this will help shift emissions away from transportation sector and convert them over to cleaner electricity fuel. Some of our upcoming projects that we're working on, so engineers, civil, mechanical, electrical, all work on these projects. Some of them that are upcoming is the Elan Solar Energy Project. So this is our largest by far and most cost-effective project located in Mojave, California. We also recently approved a Red Cloud Wind project that is in New Mexico that will bring us cost-effective wind. We're rapidly expanding our energy storage with a request for proposal that was recently issued, along with distributed energy resources, which are local resources. So all of these projects and programs help us to achieve our decarbonization goals. So a little bit about my background. When I was growing up, I actually didn't know what an engineer did. I didn't find out until I went to college, but I did know that I liked math and science. So when I took a drafting class in high school, it exposed me to how do you put something down on paper that a machinist can build. And so this was related to engineering because engineers typically solve problems. And so I selected mechanical engineer when I applied to college. And I was able to get through it and get my degree, a bachelor's degree in mechanical. And then I progressed and got my master's in engineering management. And so over the last 10 years or so, I've worked on generation projects, mostly steam and gas. But as the department evolves, hydrogen is becoming a hot topic item. Mechanical engineers also work on a water system. We have mechanical engineers working on pumps and water treatment plants, etc. So there's a tremendous opportunities for engineers at the Department of Water and Power. Also outside the department, mechanical engineers can also work within the car and airplane industry. Companies such as Toyota and Boeing, they all require engineers, and these engineers help design and build and improve existing and new technology. So a lot of exciting things in this field. Robotics and machines are also require engineers. So even such as Disneyland, the rides require mechanical engineers to help design and improve. And then everyday things like elevators, escalators, tools, mechanical engineers are involved in the development of this. So that's one side of the engineering field. There's also civil, electrical, and many more. And so with that, I'll transition I'll hand it over to Paul Lee, who is a civil engineer, to talk more about that.
Thanks, Jay. So everyone, Paul here. Thanks for having me. So I've been having a blast working for DWP as a civil engineer. Background about me, like Jay, I really love math and science. And so when I was graduating high school, I decided to apply for an engineering program with UCLA. Loved it, loved the civil program, went on to get my master's at Berkeley. And now I'm here working for the department. And what do? I work a lot on the renewable energy side. I work on wind and solar farms. I get to touch new technologies like batteries, work on electric vehicles, and I actually do a lot of energy modeling, which is where you use math, use computers, and you build out a little simulation of what you want to build. Try and get everything right before you build it in real. And so you must be asking, what else do civil engineers do, or what do we build? A lot of things that you see on a daily basis, like your roads, your bridges, your tunnels, your buildings. And we also work on a lot of stuff that you don't typically see on a day-to-day basis. So our civil engineers in the power sector, we actually do a lot of work behind the scenes. So one example is structural engineering. So people build a lot of stuff in substations where a lot of our dangerous electrical equipment are, making sure that they're safe against earthquakes, running numbers so that big buildings, they can withstand natural disasters. A lot of engineers also do geotechnical work. If you've ever built like a sandcastle, that's kind of what we do on a professional level. We build stuff underground. There's a lot of utilities and underground structures beneath your feet. That's me in that hole right there. And we do a lot just to make sure that things are safe and well hidden, just so that it's not a problem for the everyday person. So what else does a civil engineer do? Water engineering. I think Jay talked about that a little bit before. So we have a lot of water engineers for the Department of Water and Power. They work on hydroelectric power plants to deliver clean energy. We do a lot of water resource engineering, which means, yeah, we have to crunch a bunch of numbers to see. We have about like 4 million people in the city of LA. So we have to like crunch all these numbers, see how much water people need. And then we also got to crunch the numbers to see how much water is out there from the rain, snow, and groundwater. And we have to run the numbers to make sure that our pipes don't explode, trying to get that water to your taps. And we also do a lot of distribution engineering because we have thousands and thousands of miles of water lines and water pipes. So you got to make sure that everything's safe, everything works, and so that all of you can stay hydrated. So this is my favorite part about being a civil engineer, is that we get to build really, really big things. Like it's kind of crazy how big the things or the size of the project we work on. Jay talked a little bit about Pine Tree Solar and Wind. So this is one of our projects that we have, kind of a little nearby. You have to drive a little bit, but this is a huge wind farm and a solar farm. It's enough to power a small city. In fact, the whole complex is the size of a small city. So what we do on a day-to-day is that we have to run the numbers. We have to bust out our calculators and see how much energy is this going to produce? How much energy does the population of LA needs? And can we do that in a reliable manner? Can we balance the number of, or the quantity of power to the quantity of demand? And all that takes is a real engineering mindset to get those numbers right. All right, so this is a huge facility. So if you, I think the size of a person here is like the size of a pixel. So that's a little bit of a scale for you. Okay. And so what's civil engineering going to do in the future? So it's not a static field. Our profession is always evolving, like the future. Like Jay was saying, we're trying to transition more to a clean and renewable future. And civil engineers, we're going to do a lot for that too, especially with electric vehicles. There's going to be thousands, hundreds of thousands of cars that need to plug in every day. And civil engineers, we have to figure out how to build that charging network to make sure everyone's cars will get charged. We're also working on homes of the future. So smart homes, energy efficient homes that are more environmentally friendly, that doesn't have all these contaminants in them. So yeah, so civil engineers we're always looking into the future, and there's a lot of cool stuff on the horizon, being more renewable, being more sustainable. And it's been a blast just working for the department as a civil engineer. So yeah, that's for me, being a civil engineer. And I'm going to hand the baton over to Luis, who's going to talk a little bit more on what electrical engineers do. So go for it, Luis.
Hello, my name is Luis Martinez. I'm an electrical engineering associate at the Los Angeles Department of Water and Power, and I have an engineer in training, or EIT, certificate from the state of California. One of the requirements to be a practicing engineer at Ladwp is to have at least a certificate by the time you hit your 2.5 to 3 year mark, because we work for a public agency. I am under power system planning, and my group is, I work for the integrated resource planning group. So Jay, the first speaker today, is actually my supervisor and one of the best. Some of the responsibilities and focus areas that I work on are computer modeling of the power system and cost benefit analysis to inform long-term resource planning, strategy, and initiatives. So we're now starting to model out to 20, 30 years in the future. And our group helps to inform business decisions for the power system. We look at everything from all sorts of renewable energy, all types of energy storage technologies, not just batteries. We're starting to look at hydrogen. All this is on the supply side of providing electricity, but we also look at the demand side, such as energy efficiency measures and electrification of the ports, the transportation sector, of the building sector. We help ensure that we comply with regulatory requirements, and we also help inform policy at the local and state level. And one of the challenging parts about this job is that we always strive to have a good harmony and balance between cost effectiveness, environmental stewardship, and reliability. Of course, doing it all in a safe manner. And so we don't want the pathway that we take to not be reliable enough, or to be too expensive, or to not meet our environmental goals. But most recently in the future, due to more extreme weather events from climate change, we're taking a more detailed look at resiliency. How can we get our system back online if it ever does go down for a little bit? And how to make sure our programs are all done in an equitable manner. So what do electrical engineers do at Ladwp? At a high level, they can be categorized into 3 different sections: planning, and then following planning, you have detailed engineering design, and then you have field and commissioning. So I'm a planning engineer, and in planning, we plan for renewables, energy storage, as I mentioned. We plan for local programs such as rolling out rooftop solar programs, community solar programs. We do conceptual studies and pilot projects to see if certain ideas will work. We first try them at a small scale, and then once they're proven, we do them at a bigger scale, which requires more time, budget, resources. We also do transmission planning and power flow analysis to ensure that the electricity can get home to LA without the wires breaking, so to say. Electrical engineers who work in design generating stations, receiving and distributing stations. They also work on designing the controls for all this electrical infrastructure and the metering to look at real-time voltage levels, current levels, as well as the communications. Under design, we also manage major projects, and we have project managers who ensure that projects get online according to scope, to schedule, and to budget. Last, before we commission projects, we have engineers that are out in the field testing equipment to ensure it's safe and to ensure our system remains protected. So from the planning side, I work in integrated resource planning, and we help address many different questions, such as, in 10 years' time, if everybody has an electric vehicle in Los Angeles, what will the electric demand look like? And do we have enough infrastructure to meet it? What if everybody's working a 9 a.m. to 5 p.m. job, everybody gets home at 6 p.m. and plugs in their electric vehicle all at once? Can our grid sustain that? And so we ensure that our grid will be able to sustain that. But what if instead not everybody gets an electric vehicle, only every other person? So we look at different forecasting methods and projections. We also look at how renewable energy pairs along with other generation resources. What if I were to tell you that during the middle of the day in the spring, we actually sometimes have too much renewable energy on the system? This orange shaded area you see here on this chart represents solar generation, and this hashed red area actually represents overgeneration of solar. And then this black line is the electric demand. So everything above the black line is surplus. So when we have a lot of solar, we need to figure out what we're going to do with the excess, or else it will overpower our system. So in planning, we look at how much energy storage we'll need to address all the overgeneration of solar. So that's pretty exciting. We also do a lot of analysis, and the cool thing is that all types of engineers can do this type of analysis. I happen to be electrical, but my supervisor is mechanical. And as Paul said, as being a civil, he does a lot of analysis too. And so being good at math and science, but having good critical thinking skills, as well as being able to communicate both written and orally, will help you do analysis and present your results. For instance, here on the left-hand side, we looked at 3 different case studies, study A, B, and C, and we looked at which will reduce greenhouse gas emissions the most for the power system, which is one of our main goals. And we see that the blue line, line B, it reduces greenhouse gases the most. If we look at the chart on the right, we look at what the costs will be, and we see again that the blue study has the greatest amount of savings. So this helps inform where to lead our power system next. Last, I'll say that in planning, we do a lot of studies, and we collaborate with local partners and stakeholders in our area to ensure that we address everybody's needs. For instance, one of the major studies we're doing right now is called the 100% Renewable Energy Study that was mandated by the Los Angeles City Council for Ladwp to investigate the pathways and investments required for the city of LA to one day be powered 100% through renewable energy. And so we've enlisted help from the Department of Energy through its National Renewable Energy Laboratory. We're working with local organizations and nonprofits, as well as environmental groups such as the Food and Water Watch, the Sierra Club, other local industries like Southern California Gas, Tesoro, our transportation agencies, and local academic institutions like UCLA and USC. Last, I'll say that in order to be a successful organization in planning for a renewable energy future, we need resources to inspire, motivate, and train engineers. And if you're a prospective engineer and want to join the Department of Water and Power, once you're in college, you have the opportunity to apply for the student engineering program. And if you get accepted as a new engineer under the power system, we actually have a rotational program called the New Engineering Associate Trainee Program, or NEAT. And they'll actually expose you to planning, to design, to field and commissioning. Both Paul and I are alumni of both of these programs. We also have employee organizations to ensure your success as an engineer. For instance, this picture up here is of the Society of Women Engineers at Ladwp. And everybody in this picture is an engineer. We have more useful links. Sorry, they're not hyperlinked, but if you go to ladwp.com, there's a section called About Us, followed by a subsection called Careers. In there, you'll find different pages, such as an engineer recruitment page or an internships page. That'll really help you if you're interested in becoming an engineer one day. And with that, we're happy to take any questions you may have. Thank you.
We do have, if you can hear me, thank you. Great presentations and the summary of the department, and also on the career disciplines and what you do in the different aspects of renewables. We do have a question from Isidro Valdez from Sun Valley Magnet, which is in our, pretty sure it's in our service area in the San Fernando Valley. He wants to know, what things do you have to take into consideration when making plans such as a transition into renewable energy?
So this question can be answered in multiple perspectives, from design build phase to the economics of it. So I'll have Luis and Paul answer first, and then I'll wrap it up. Luis, you want to start?
Sure. Okay. So in terms of what should be considered for renewable energy, I think that may paraphrase the question a little bit. It's Impacts to the local community. Will construction of new projects, say, will they take up a lot of land? If it's solar projects, we have to do environmental impact reports to make sure we don't displace a certain animal species. And we have to, we look at costs and making sure that while we all want more renewables, which projects should we bring online first? Will it make electricity more expensive? Things of that nature. That's what I'll reply for now.
Yeah, so I guess I'll take another part of the question. So there's a lot to consider, but maybe I'll answer just like one part. Just my own perspective is that when you want to transition, you should take stock of what you already have. Now, it might be really cool to think that, okay, we got to get rid of everything and then just replace it with solar panels and wind turbines. That's not really the case, because we actually have a lot of equipment already, a lot of existing infrastructure that can still do a lot of good. And so it's not like we're just tearing everything down and building something new. You really have to take into consideration what you already have, because we still have a lot of good things, and we need to use that and then transition to a clean energy future.
I'll answer on a higher level in terms of the department's goals. So our goal when we plan for projects is always to balance reliability, cost, and environmental stewardship. So as Luis mentioned, those are our 3 pillars for planning. And when we transition towards renewable energy, we take into account how fast do we get there, because typically the faster we ramp up, the more the cost. And then how do we get there? Do we employ hydrogen? Do we employ batteries? So all of these must be considered when we take into account different scenarios. So when we do our planning, we model these scenarios to look at what the outcomes are in terms of cost and greenhouse gas emissions. And then we present that to management along with stakeholders. And then they'll help us to drive the decision on what will be our plans for the next 20 years or so.
We have another question, which is a little different from Mr. Parsons. He wants to know, if a high school student doesn't go to college but wants to do a green job, would that labor come from IBEW or other union apprentice training programs? I can add one thing. The IBEW, almost all of our employees, whether engineering or whatever classification, are represented by IBEW Local 18. They do have a program called Utility Pre-Electrical Craft Helper. You don't need experience just to be 18 to have a driver's license, but you have to apply directly with them. There's a waiting list, but then the idea is they rotate you into different jobs and then to help prepare you for civil service exams. So that's one thing. Another is that there are courses on electricity and also water through Los Angeles Trade Technical College. I believe in LA County, Rio Hondo is another one, and Mount SAC, which are 3 community colleges in LA County. So those of you that are out of LA area, Northern California, you'd have to check with your local community colleges. You can, if you check the local community college districts in your area, and some of them will have training programs in in the skillcraft trades. Also, I might want to mention that other than the UPTC, we also have offered some courses through LA Trade Tech for some of the beginning classifications. So you can check there, but actually to be hired, generally full-time positions at Department of Water and Power as engineer or skillcraft that take civil service exams. But for engineers, we do have campus recruiting where our recruiting team will go to different college campuses and interview seniors, for example, in engineering. The other thing too, it was mentioned about our student engineer program. The applications for that usually are people that are going into engineering. Those are mostly summer jobs, but can also go during the year. But the application is available usually in the fall of a sophomore year. So in order to be eligible to actually work, you have to complete your sophomore year, beginning your junior year. So in the fall of your sophomore year in engineering school is when you would apply for the student engineer program for the following summer, and some jobs are able to be continued during the year. I don't know if you guys want to add anything to that, if any of you are student engineers. But that's my understanding of that one program.
Yeah, you
Yeah,
covered it. You covered it well, Walter. One other thing I could add is that one of the benefits for the Department of Water and Power is that they really invest in the employees. So even if you start out, say, as a drafting technician, you can always go back to school and the department will reimburse for the tuition. So that's a huge benefit on one end of that.
In fact, they just changed the system. It used to be on for tuition reimbursement. It used to be that you had to take courses specifically related to your area where you were working at that point. Now they've changed it so that you can, as long as you go to school and take courses related to any, any job at the department or any career path, they'll pay the full tuition. You can go to, USC and get a bachelor's or master's or, private tuition. They'll even pay the whole thing. So you work and then you take courses and the tuition department pays it. So it's a quite amazing benefit that way. Let me see if there's any, looking at the chat, the question. Oh, there's some more questions in the chat. Let's see. One question is, LAG considering pumps, hydro storage in order to store surplus solar energy during the day? I guess Paul was typing the answer, but we do have one already. We have a huge pump storage plant at Castaic. It's actually on the north side of Castaic Lake. We have a pump storage, takes water from Pyramid Lake, and then they generate electricity during the day, and at night they pump it back up. And then I know that we were exploring a similar situation around Hoover Dam. I don't know where that is. I know we were doing research on that.
Yeah.
Another teacher, actually, Miss Perez, Marisol Perez, who is at Fremont High School, is one that we're starting a relationship with her class. Possible, I think we'll be adopting it, her program. But she wants to know what happened in Texas. Is that something that can happen here in California? Can our grid sustain harsh temperatures?
Luis, you want to take that?
Sure, I'll begin. Unfortunately, we're all seeing more and more extreme weather events, which is one of the main reasons why we have our goals for decarbonization to not only stop, but try to reverse that. And while we may not all get hit by the same weather events, and maybe ice storms and blizzards are less common in Southern California, but certainly not in all of California. Like Texas, we have other events, primarily in Southern California, our service territory, earthquakes, and most recently wildfires. And some of the things that help us is that, as Jay said, we're vertically integrated. So we have generation, transmission, and distribution. And we're also connected to our neighbors, our neighboring utilities. We're actually connected in the Western United States electrically, all the way up as north as Canada and down south as Mexico. And in such extreme events, we can actually help out each other. So this past summer, actually, we had a series of heat waves here in the whole Western US, but Ladwp was helping provide electricity to some of its neighbors that were having more severe blackouts. But that is one of the reasons, too, why I mentioned we're having a heightened focus on resiliency, where reliability may mean keep your system as stable as you can constantly, whereas resiliency is if you take a hit, can you bounce back? How fast can you bounce back? And everything from energy storage for events like this, having a geographical and resource diversity. We have a lot of solar up in Nevada, and Nevada gets hit with a storm. Well, if all of our eggs are in that basket, it's not as good. But if we have solar in different areas, if the solar goes away at night, but the wind picks up and helps provide electricity, that's why we have to do very good diligence in our planning.
And also on the water side, one of the reasons to increase the local supply is that the aqueducts can get cut off. They all cross the San Andreas Fault. So if we increase our availability of local supply sources, that gives us some kind of a buffer. It gives us time to make the repairs, and we can draw more from our groundwater basins, et cetera. That's also one of the key things. But we're also, we're investing not only in renewables, but we're also investing billions of dollars in infrastructure to increase reliability. We also on the water side have certain pipes have been put in that are resistant to earthquakes. Electricity, we're replacing a lot of transformers throughout the whole city. And doing everything we can. I think they're looking into putting in certain lines and infrastructure related, so it's resistant to wildfires and this kind of thing. So, the one thing that Texas doesn't have that we do is they're not integrated. They have their own system and they're not integrated to the other areas. There's basically, I believe, three main systems in terms of electrical grids. We're tied in with the Western power, and then there's an Eastern one, and I believe a Midwestern, and then Texas has its own. And if one of the things, if they had integrated with some of the other areas, it would have helped. Let me see. I think we have more questions. Look at the chat here.
Yeah, so I think there was one question that I prematurely answered. So there was one by Angel on how does business and administration fit into the field of engineering, and I was trying to answer that very much so. So I'm pursuing an advanced degree in public administration. It's very helpful to have these types of dual degrees because it's not just about engineering within the field of Ladwp. So I don't know if Jay or Luis wanted to touch on more of the MBA side, but definitely they do all kind of fit together.
Yeah, especially at the Department of Water and Power, since we are a business for our customers, in that we want to keep the rates low, but we also have other goals such as beefing up our system, maintaining reliability and emissions reduction. A master's in business administration does help with those factors because it helps you understand what the market conditions are and how to develop business plans. And all of that really feeds into boots on the ground, where when you actually deploy the work, you need engineers to do. So we work hand in hand with MBAs and management, and also the field folks. Department of Water and Power is very collaborative. We work with a lot of different agencies and internal stakeholders and such.
We also have, there's some civil service classes that we have that are throughout the city. We're part of the city government and civil service, which is, hiring through competitive exams, hiring and promotion through exams. There are certain classifications. Management assistant is sort of a beginning one in the administrative field. We in the city, Los Angeles has a classification called management analyst, which is sort of journey level administrators and budgets, personnel, so the complete administrative functions a lot of them are handled, the budgets, the personnel, administration is handled by the management analysts, and there are, positions within Ladwp and all over the city in terms of general administration. And I'm a principal public relations rep, manager of education outreach, and we do have public relations staff, but we've got 20, 30, 20, 25 people in the PR public relations area, but there are something like 1,200 engineers and 2,000 skilled craft workers. So in terms of getting a job with LADWP, a much better, a bigger chance getting one as an engineer than you do as a PR person. I don't know the exact number of management analysts, but it's got to be scores, you know, because every division has several. You know, in our division, we're a relatively small division. We've got about, I think, two in the management class of it, and then there's like 3 or 4 administrators that do budgets and personnel, and that's just a small division. So they're all throughout the department. There are management analysts, and then the administrative managers above that in another classification. We also have accountants. You know, we have a lot of accountants. That's also a classification that we recruit for as well. So there's no more questions. We're at the 2 o'clock limit, and I don't think we have any more questions. So just looking. So I
Did we get to a question where from Heather Brooks?
Oh,
Yeah.
the one about was that the local supply sources?
Where it's about students that struggle with math and science.
Oh, okay. I don't think I saw that one.
Yeah,
Any of you want to take that one?
I can start, or you want to start, Paul?
Oh no, you can go for it, Luis.
Yeah. Okay. I was one of those students. I'm the first person in my family to go to college, and not only was there no other engineer in my family, there's no other person who went to college. So it's definitely not a prerequisite to become an engineer. And I know in college, you'll usually face calculus. And so some high schools offer calculus, pre-calculus. Try to take the AP courses if you can. But if you're struggling, I think the most important thing is to not give up, to seek out your local resources. I mean, I had to repeat a couple classes in college, and it took me a little bit longer to get my bachelor's degree, but it was well worth it. And if you can tap into the love of how engineering answers the why of how things work, that is a huge motivator when the numbers look like a foreign language and the science equations are over our heads. Our love of how cars work, how energy works, that can help us persevere.
Oh, that was a beautiful answer, Luis. Sounds like they want you to do a private visit. But, I don't know. Are we out of time? So we're at 2:02.
I think if there are no more questions, you guys can go ahead and finish up.
So anyway, we want to
much,
thank everyone for participating, and you know, I know this will be recorded for future viewing, and we thank everyone for listening. And if you have questions, you know, you can go on to NEPRIS and reach any one of us by email. Walter Zeisel, Paul Lee, Jay Lim, Luis Martinez. You know, we're at our name dot at LADWP. It's you know, like walter.zeisel at ladwp.com. So thank you very much for attending, and we hope that you got something from this chat, and we wish everyone well.
Thank you, everyone.
Thank you.